while waiting for Ikmal to join, so let us just start a quick discussion on the foundation and understanding on the hypothesis testing. Uh, Basically, we are looking at the evaluating the assumptions. Uh, so specifically, we will learn how to evaluate the assumptions that underlie hypothesis test, which is a critical step for drawing valid conclusions from data.
Hi, sir. Okay, so that sounds interesting. But, sir, what kind of assumption are we talking about, sir?
Great question. Every hypothesis test, whether it's a t-test or it is a z-test or even ANOVA, analysis of variance, or even ANOVA, it's built on certain assumptions about the data, where if those assumptions are not followed or violated, the results may be misleading or even can be invalid.
So, sir, it's like checking the rules before applying the test.
Exactly. So let's start with the normality assumption. Lisa, have you heard of it?
Oh, just a little, sir. Yeah, is that the one where the data has to be normally distributed?
Yes. Many tests like t-tests assume that the data follows a normal distribution, particularly when the sample sizes are small. So if this assumption is violated, your p-value may be wrong or inaccurate.
So, sir, how we check the normality, sir?
Normally, we can use the histogram, or sometimes we can use the QQ plot. QQ plot, or it's some researchers, they used to use other statistical tests like Shapiro-Wilk or Kolmogorov-Smirnov test, KS test, we call it. So now let us just go on into the independence assumption. What do you think of? What do you think that means? Independence assumption means.
Okay. Maybe that the data point shouldn't be influenced by the others.
Yes, you're right. So for most hypothesis tests, observations must be independent of each other. If we comparing test scores from the same students before and after a class, we are dealing with the paired data, and the independence assumption is violated.
So, sir, in that case, we use a different test for each one.
Correct. So a paired test, a paired t-test, a paired t-test instead of an independent t-test. So recognizing the correct data structure helps you to select the right test and apply the right assumptions. So now another key assumption is equal variances. Earlier we talked about the independence, normal distribution. Now we are moving into the equal variances or homogeneity of variance, particularly for ANOVA, analysis of variance. ANOVA means analysis of variance, and the independent t-test.
So, what happens if the variances are not equal?
If variances are unequal or not equal, the results can be distorted. So, but don't worry, there's a version of t-test which called Welch t-test that corrects the unequal variances. So we got a particular test for to fix the problem.
Okay, so just want to ask, how do we test for the equal variances?
For equal variances, we can use the Levin's test, or more commonly, we can use the F-test. If the p-value from the Levin test is low, then we can reject the assumptions of equal variances. Yeah. So now let us talk about the random sampling assumptions. Okay. So these are why is random sampling is important in statistics.
Okay, because it helps avoid bias and the sample will represent the population.
Correct. That's right. So the sample will represent the population. If the data is not randomly selected, your conclusion might not be generalized. Okay, so this is particularly critical when you are drawing inferences about the population.
So, if we take data from one school and apply it to another school, is it possible? Is it too risky?
Yeah, it's very risky, really.
Okay.
That violates the external validity. So let's do a quick recap. These are main three common assumptions in hypothesis testing.
Okay. The one we're talking about is normality, independence, and equal variances.
Excellent. Excellent. Yeah, these are the three assumptions that we were discussing about hypothesis testing. When it comes to hypothesis testing, we can look at the normality, independence, and also equal variances assumptions. So, what should we do if one of these assumptions is violated?
Okay, either one an alternative test or
Mhm.
transform the data.
Correct. Brilliant answer. For example, if normality is violated, we might use a non-parametric test like Mann-Whitney test instead of just a t-test. Okay? So now let me just quickly ask you some mini quiz questions here. Quizzes, especially when it comes to assumptions in action. Quick fire. Okay, I'll say a situation. You tell me if the assumption holds, right? Now you can take down some important information in the situation. I will give you a situation, then based on the situation, you try to give me the answers. Okay. So situation one, comparing the heights of students in two different classes. Okay, given that the sample sizes are 10 each.
So check for normality and equal variances.
Correct. Yeah, that's right. We have to check for the normality because we've got two groups, so we have to 10. So we want to look at the heights of the students, and in two different classes, we have to look for the normality and also the equal variances. Now let me just give you another situation. A situation two, measuring stress level of employees before and after a wellness program.
Before and after. So we use a PET-T test because the data is not independent.
Correct. Very well. Very good. Okay, so now let me bring you to the situation three. Okay, maybe I give you another one. Situation three. You notice your data is skipped, okay, either left or right, skipped. What should you do?
We transform the data, sir.
Perfect. Okay. So now let us move into the maybe into the wrap up kind of questions. We discussed on why assumptions matter. Why it is important to evaluate these assumptions before even performing a hypothesis test.
So we don't end up to making wrong conclusions. Because when the incorrect assumption will give misleading the p-value or the test statistics.
Statistics is powerful, but only when we respect the rules. In our next session, we will explore how to choose the right hypothesis test based on data type and also the structure. So,
Looking forward, sir.
excellent energy. Yeah. Okay. All right. So now let us go into the, but before that, we go into the ethics. I would like to know your level of understanding the ethics implications or ethics in hypothesis testing and how to conduct research responsibly. So, so let's explore something equally important as calculation, ethics in hypothesis testing. And why transparency and responsibility matter in research? Do you have any answer?
Ethics, sir, just want to ask ethics, like copy others' work, is it? Copying.
That's one part of it. That's one part of it. But in hypothesis testing, ethics means making sure or ensuring honesty, objectivity, fairness in how we collect data, analyze data, and reporting the data.
What kind of unethical things happen in hypothesis testing, sir?
Good question, Lisa. Commonly, the common ethical issues this include like p-hacking. P-hacking means manipulating the data or repeating tests just to get a significant p-value. So this is what we call p-value hacking. So we're supposed to report whatever p-values that we're getting, but what we are doing is we're trying to analyze, test, and test again until we get the p-value significant. Other than that is you can see selective reporting, where we only report results that support a hypothesis. Okay, we do not want. I mean, we normally don't report the insignificant hypothesis. This is it's not ethical as well. And also, finally, I mean, you can also see some problems like some unethical methods will be the data fabrication, where making up results, making up results entirely.
Do people really do that, sir?
Unfortunately, yes. Yes, and it can be misleading conclusions that harm society also, especially in the areas of like medical field, medicine field or finance, or sometimes the government policies or public policies. So now, so now let's talk about the transparency in hypothesis testing. Lisa, what do you think about the transparency means in this context?
Maybe sharing and show how you did your research.
Correct. So great. So transparency means clearly explaining your data sources, transparent how you got the data, or the hypotheses that you obtained or you built, you established, and also the statistical methods that you are using, assumptions that associated with those statistical methodologies, and also the limitations of the methods. Yeah. So this is how it goes.
Okay. So others can understand and repeat what we did.
Exactly. This is what we call as a replication or reproducibility. A responsible researcher normally makes sure that others can verify and replicate the result, reproduce the results. It builds trust in the science. Yeah.
Okay, so what about responsibility? Is that different?
Good distinction. Responsibility means protecting privacy and informed consent. And also responsibility in this sense, we can also say avoiding biases. We have to be fair and also making decisions that prioritize the public well-being over personal benefits.
Like not hiding any bad result or just want to look good.
Yes. Also declaring the conflict of interest. Like if a company funded your study or you got a grant and all that, no, you should disclose, and they might benefit from the result also. So now let us do a short case study. Okay, take it down and tell me whether it is okay to go or not Okay, whether it is ethical or not. So let me just give you this scenario, and you can try to evaluate it. Suppose a researcher, okay, suppose a researcher is testing a new drug. The results found to be mixed, but they only publish the positive findings. Is it ethical?
Definitely no, sir. Because they are lying by leaving out the bad parts.
Anything to add?
Because the people might believe the drug is better than it is.
Exactly. This is what we call as the publication bias. It basically distorts the scientific understanding and can cause the real harm to the society. And here's another scenario for you. Let's say a student runs 20 different t-tests, hoping to get a significant p-value and finally gets one. Okay. I repeat, a student runs 20 different t-tests, means repeating. And a particular guy is hoping, he's trying to get a significant p-value. And finally, he got one. And they publish that result alone. What's your thoughts?
My thought is it's a p hacking because they are fishing for the result.
Correct. That's unethical. It increases the chance of false positives and the results that look real, but they're not.
Yes.
So now let us do a mini quiz, ethical practice check. Okay, let's test your ethical instincts with a mini quiz. Okay, so let me just give you a couple of scenarios, and you tell me whether it's unethical or ethical, and please try to provide a brief reasons, provide logical reasoning why and all that. So
Okay.
shall we? Okay, so let me
Okay.
just give you the first scenario. First scenario, you can take it down if you need it. Need to take it down. Okay, so you didn't get the result you wanted. For example, you didn't get the results you wanted. You decide not to publish. Is it ethical or not?
It's unethical because I should share the result whether it's positive or not.
Correct. Good. So next, let me just give you another scenario. If you tweak the hypothesis after seeing the result.
It's really bad, sir. It's like a cheating the process.
Okay. Another one is if you offered a reward to hide certain findings. Is it ethical or not?
No, definitely no, sir. You should disclose all findings truthfully.
Excellent. Ethical researchers respect truth more than outcomes. So you must remember this. So even you got a wrong result or the result is not beautiful or whatever, you can just report whatever results that you get. Okay. Now let us look at the research integrity. Let us warm up on research integrity. So let me ask, why should we care about ethics in hypothesis testing?
No, because the people really rely on research to make important decisions.
Mhm.
And if research is dishonest, it can be bad policies or harm to others.
Well said. The goal of research is not just discovery. It's honest discovery. So next time we should explore how to write a transparent research report that includes limitations and also the assumptions. Yeah.
Looking forward, sir.
Okay. So great. So now let us go into the simple linear regression. So I think we are just done the discussion on the hypothesis testing chapter. Topic 8 is done. Topic 8 is done. Then we are moving into the introduction to simple linear regression. Okay. So okay, now let me just start with the question maybe. Okay, maybe I will put it like this. we go into a very practical statistical method, which is on the simple linear regression. Have you heard of this term, simple linear regression before?
Yes.
Okay.
Yes,
So,
but
okay. So,
because I heard some, I heard a few times, but never quite understand what is 4D.
oh, I see. Okay. At its core, simple linear regression helps us to model the relationship between variables, between a minimum of two variables by fitting a straight line. Okay. So normally we use it to predict outcomes and understand the trends. Let's say we want to know how hours of study influence the exam score. Okay, what kind of relationship would you expect? Okay.
I expect that more hours mean better scores. Means that it's a positive relationship.
Correct. Then you can see hours of study and also the exam score. If you study longer hours, you prepare more, then you can perform better. Okay. So if we plot each student's study hours, okay, and their corresponding scores on a graph. Okay. So we would like to see a trend going upwards. You can see a positive or upward sloping trend. Okay, not a line. And we are not trying to connect the points, but we are just put them in points. Okay, okay, we need to say you have the x-axis and y-axis. So you just plot x-axis is represented by the hours of study, and y-axis is represented by the exam scores. So as we plot them, if you look at after you plotting them, you look at the trend. You can see a positive and upward trend from your left to right, going upwards. From your left to right, you can see, and this is what we call a positive trend. A positive trend. So therefore, you can see the simple linear regression helps us to capture the trend in a mathematical equation. From the trend itself, we can come up with an equation, which can help for us to do many things, including predicting, forecasting, and all that. We can use the same trend to do the forecast for the future. So now let us just go into the. Let me just introduce to you the basic form of the equation. The basic form of the regression equation is y equals to alpha plus beta x, a plus b x. In some textbooks, you can see it is a plus bx or alpha plus. Sometimes alpha, we use the term alpha, it's a. We use the Greek letters. In Greek letters, normally they use alpha, beta, gamma, this kind of things. This kind of terms. Actually, we just treat it as alphabets. Okay, so but you must know the y. You can even take it down. Y, you can write it down. Y equals to a plus bx. You probably would have seen this in the chapter called simple linear regression, right? So y means the dependent variable, the relying variable. Okay, y is relying on x. Okay, the exam score. The exam score is dependent on the number of hours spent on study, hours spent on studies. Okay, so y dependent variable. This is what we are trying to predict. Predict this variable, y variable. Whereas if you look at the x variable is independent. It is standing alone and can influence other. Also known as an exogenous variable. The predictor, the so-called the predictor, and the alpha or the a here will be the intercept or the constant. The value of y. What will be the value of y when the x is 0? That means even there's no value for x, you still have y. That means even you do not spend any hours on studying, also you can get some marks. So exam score and hours spent on studies and also the exam score. Okay, so we will have some value that will be the intercept, the alpha here. And also if you look at the slope beta, we're talking about the change in y. the slope, or the gradient or the slope, where we can say the change in y for every 1 unit change in x, every 1 unit change in x. So now let us use an example. We can take it down. Okay, we take it down. Suppose we collect data and we got, let's say we obtain an equation. The equation is like this. Let's say we get y equals to, you can take it down, y equals to 40 plus 5x.
Y equal to 40 plus 5x. Okay.
So
if some studies for 4 hours, we plug in as x equal to 4.
correct. That's right. That's right. Let me just elaborate it. We need to say y is the exam scores, assuming x will be the hours of studies. So if x is hours of studies, so you want to see roughly, you want to predict the exam score. Just plug in 4. You can try it. If you calculate, what you get? What will be the score?
So y will be 40 plus in bracket 5 times 4 equals to 40. So 40 plus 20 will be 60. So their score is 60.
Fantastic. You're right. You're right. So and if someone studied for 10 hours, what do they get?
10 hours, 10, 40 plus 80 plus, that is 90, sir.
Very good. That's how we use regression to make prediction. So now let us go into maybe a quick homework for you, a hands-on practice and model building. Let's see whether you can do this, whether you can handle this or not. Okay. Let me just spontaneously give you some values. And then you try to use your calculator, or you can try to use any software. Try to calculate the equation. Or maybe let me just give you the answer also. But you take it down. Okay. Let's say we have x. I give you the x values and y values for the same examples where exam score is dependent on the hours spent on study, or study hours, we can say. Yeah? So let's say the study hours x is 2, 4, 6, 8, 10. Simple values. You just write there, put a 2 columns over there. Okay, column 1 and column 2. Column 1 you label as hours x, and column 2 you just label as a score y. Okay. So 2 jam, 4 jam, 6 jam, 8 jam, 10 jam lah. So 1, 2, 3, 4, 5. Let me just give you 5 different values for hours and 5 different exam scores. For example, for 2 hours, the exam score, the y value will be 50. 50% or 50. For 4 hours, the value is 60. 6 hours, let's say 65. Take it down. 50 for 2 hours, 40 for 6 hours, 65 for 60 for 4 hours, 60 for 4 hours, 65 for 6 hours, 80 for 8 hours, 80 for 8 hours, and let's say 90 marks they got for 10 hours, 90 marks. Okay, now if I use a software, a formula here, let me just calculate. I use a formula for software. We can get the equation. You can try. You can check whether you're getting y equals to 42 plus 4.8x.
So what does the 4.8 mean, sir?
That's the slope. That's the slope for every additional hour studied. The score increases by 4.8 marks.
And then the 42, sir?
And the 42 is the intercept. That's the intercept. It shows the expected score if a student studied 0 hours. That means even the student never studied at all, the student will still get 42. But it may not be always realistic, but it anchors our line on the y-axis. Basically, it's an approximation only. See? All right. So I think it's already clear. So now let us jump into using the values. Let us go into a scatter plot, maybe a scatter plot. So in scatter plot, each point shows one student's data. Okay. Two for earlier we discussed 2 hours. The first one is 2 hours. One student studied for 2 hours, then he got 50 marks. Another student studied for 4 hours, he got 60 marks. Third student studied for 6 hours, then he got 65 marks. 8 hours, 80 marks. 10 hours, 90 marks. So now the regression line cuts through these points to minimize the gap. Okay, or this is what we call as the residual.
Residual. What are those, sir?
A residual is the difference between the actual value and the predicted value. A smaller the residual means better fit.
Okay. So if the prediction was 70, then the student actually scored 68. So the residual is -2.
Correct. Correct. That helps us identify how accurate the model is. And now, what if a student studied for 8 hours, but the score is only 55?
That's much lower than expected. So it's an outlier.
Yes, it is. It is what we call as an extreme value or an outlier. Outliers can be heavily influence the slope, and it can distort the prediction. So that's why it is important to visualize your data before jumping into any analysis. Right. So now let me just check you on your level of understanding in the coefficient of determination, also known as the R squared. R squared and the model strength when it comes to regression. Yeah. So let's introduce a powerful concept, R squared or R power 2. Basically, it tells us how well the regression line is best fitting the data or line fits the data. R squared values ranges from 0 to 1. The highest R squared value can be 1, which is not possible. Like, normally, you cannot see that happen. And 0 means completely no relationship. So R squared, when R squared is 0 means it's no relationship at all. The two variables are not related at all. And R2, R squared 1 means it's perfect prediction. Perfect prediction. So X being a perfect predictor for Y. Even practically, this will never happen. So normally what we can see, you can see a partial prediction. Normally between more than 0, less than 1 in between. So for example, if let's say R squared is 0.85 means very good. This is 85% of the variation in Y. In the exam score Y is explained by the X, the study hours. In this case, we are talking about the study hours. Are we clear? Lisa, can you hear me? Lisa, are you with me? Can you hear me? Lisa, can you hear me? Can you hear me, Lisa?
Oh, sorry, sir. My internet problem.
Okay, no problem. So I was talking
Okay.
about
the R means that 80%, 85% just now.
Yeah. So
Of the
85% of
variation.
the variation in the exam score is explained by the X, the study hours. So do you?
So, sir,
Yeah.
the higher the R2 is the better, is it?
Yes, but we must be very careful. higher R doesn't mean causation here. Okay. It only shows the association, the hubungan,
Okay.
association, the
So-
correlation. Yeah.
So it's like an ice cream sales and shop attacks. So they go up together in the summer, but it doesn't cause by each other.
Brilliant example. That's a spurious correlation, we call it. Fantastic. Good answer. Clear understanding. Great. So now let's practice. Let's practice. Let me just give you, going back to the previous equation that I gave you, y equals to 42. If you go back to the, look back to the equation, y equals to 42 plus 4.8x. Y equals to 42 plus 4.8x. You can even take it down or you can go back to the same equation. So now I want you to calculate the y, predict the y. Okay, predict y, you can take down. Let me do three predictions. Do three predictions. So predict y, first one, question one. Predict y when x is equal to 7. Okay, that's the first question. The second question, predict y when x is equal to 0. The third question is predict y when x is equals to 15. Can you do that, Lisa?
Okay, can. So 142 plus in bracket 4.8 times 7 means 42 plus 4 times 7, 33 points is plus 42, 75. For the first one is 75.6. So the second one is when x is 0. So y 42 plus so it's not intercept because it's 0. So number 3 is y 42 plus 4.8 times 3 is 15. So 42 plus 4.8 times 15, 72 plus 42, 140. So, sir, for the one number one, when x is 7, so y is 75.6. Okay.
Correct, that's it.
So, okay. For number 2, when x is 0, there is no intercept. Y is 42, but no intercept. Okay.
No slope, no slope. Yeah.
Okay. For number 3, when x is 15, y will be 114.
Fantastic. Correct answer.
But so it doesn't make sense to predict y when x is 15 if we don't have any student in that range, sir.
Can you repeat, Lisa, if you don't mind?
Okay. What does it make sense to predict y when x equal to 15 if you don't have any student in that range?
That's a sharp observation. That's what we call extrapolation. That means predicting outside, beyond the range of observed data. And the problem with it is it is a bit risky, because we are going beyond the range of the observed data. But normally, it has some criticism where it is often unreliable.
So it's safer to stick with the range that we observe.
Absolutely. That ensures your prediction. Okay. So let's talk about great, good, very good. Let us talk about the ethical side of using the regression models. Numbers can be powerful, but they can also mislead. Okay, for example, you can see using bias or incomplete data, reporting only models with high coefficient of determination or high R squared. And that is one problem. Another one is hiding assumptions or the residuals or claiming causations from just using correlation. From using correlation, we cannot claim for the causation. So these are some issues here.
But it sounds dangerous, especially in fields like medicine or public policy, right, sir?
Yes, that's why ethical researchers, they must disclose their assumptions, and also they should test for model fit. They've clearly discussed its limitations, and sometimes they also should avoid the p-value hacking or p-hacking, where they tend to run many models to get good results. That is wrong. And also they should maintain the transparency with the data analysis.
So ethics is just isn't about not lying, but is about being honest with the whole process.
Precisely. Good science is open, basically, and replicatable, and people should humble about it. Its boundaries, basically. Yeah. So great understanding, Lisa. So now let us just do a quick recap and let me just do a knowledge check. This is by throwing some questions. So I'll ask you and you answer. Okay, so now first question to you. Um, what does the slope in a regression line represent?
The change in y for each unit increase in x.
That's right. That's right. Okay. What is R squared?
R squared. The percentage of variation in y explained by x.
Fantastic. Clear answer. The most correct answer. Uh, so why should you never assume just from regression?
It's a causation.
uh, nice. Okay. What is extra? I mean, sorry. Why is extrapolation is dangerous?
Extrapolation is dangerous. Because you are predicting values outside the observed data range.
Good. Yeah. So what makes a regression analysis ethical?
Transparent method, uh, honest reporting, and no data manipulation.
Excellent. Nice. Very good. So now let us go into the closing reflection. Closing reflection. So you have done a phenomenal job today, where from understanding equations, basically interpreting graphs, ethics, even models. We talked about the model strength R squared. This is the full package actually.
Thank you, sir. I feel much more confident now. I might be even try this with my own survey data.
Okay. So that's the power of regression. It connects real life with mathematics. So shortly, in future, you should be able to look at how Python works or Microsoft Excel. Right? Okay. Now what we do, we take a short break. Okay. We take a short break, maybe about how long do you need it for you to digest? How long?
Can 15, sir?
Okay, you can take about 15 minutes break. So during your break time, please study on the sample correlation. Yeah, I would like to just go through the lecture, go through the formulas and everything. not the lectures, the scene and the formulas, everything.
Mhm.
So we will have some discussions on the chapter. So once we are done with the discussion of the chapter, I will be showing you a quick analysis of regression. I'll be showing you analysis on data analysis using Excel. Basically, I'll be showing you data analysis using Excel after our discussion. Yeah. So now we can take 15 minutes break from now.
Okay, thank you, sir.
Thank you. Okay, I think we shall start now. So while waiting for Lisa, Ikmal is here. So Ikmal, as you requested, I got your email asking me to show you on the data analysis using the Excel. Yeah, so great. So now let me just quickly show you how to analyze the correlation and regression. So I hope you can see my screen, Ikmal. So now for the analysis, okay, especially you can start from the doing the scatter plots. So if you look at the scatter plot, this is how the scatter plot should be. So we go back to the question paper, you can see there are three main variables that we have. Just a minute. Just give me a minute. So we would like to look at the scatter plot. The scatter plot. We would like to produce the scatter plots based on the variables here. So I'll be showing you how to do the scatter plots. And also, if you look at here, this will be the answer for the regression equation, where we have the coefficients here. You can find the coefficients over here. So these are the coefficients and the standard errors for the coefficients. And we have the p-values in the regression analysis. Okay, so now you can see here we have two variables. We have two variables, is the job satisfaction and motivation towards the intention to leave, and also we have included a gender. We have included an additional variable, gender, to as a control variable to look at the robustness of the result. Okay, so now let me just show you the data one more time. So you can see this will be the data set. This is the data set I gave you. So we have about 50 participants, 50 respondents for this data. So the N is equals to 50, which is more than 30 observation. So it means there will be a normal, the normal distribution is confirmed there because we won't have any biasness in terms of a normality. And next we can see we have the gender. We have the gender. So you can look at the coding key here. So you can look at the participant numbers, the employees gender, the employees, the one for the men and two for women. And you can see the participant's age. This variable shows the participant's age and type of contract over here. So the type of contract, you can see one for full-time and two for part-time, highest education level completed, zero for no formal education, one for some high school education completed, two for two for high school diploma, three for professional diploma, four for bachelor's, five for master's level of education, MBA, MA, Master of Arts, MSc, then six for PhD. So this is the respondents' level of education completed, and also we have the scores for the job satisfaction, turnover intention, and also motivation. So mainly we are looking at these variables here. We want to look at the relationship between the job satisfaction, turnover intention, and also the motivation for the correlation. We're looking at the turnover intention. We want to look at the correlation between the turnover intention, job satisfaction, turnover intention with the motivation. And one more set, we want to look at the job satisfaction and the motivation. We want to look at the correlation. So before we go into a formal correlation analysis or formal test, so the basic way or the preliminary test for the correlation will be a scatter plot, stimulating or producing scatter plots. So that is what we can see here. Okay, and shortly I'll be showing you how do we get this correlation. So for that, what you can do is you have to get this cause, your motivation, intention to live, motivation, job satisfaction. Okay, and also intention to live with the job satisfaction for you to get the correlations. So you can see we have 3 sets of data. So in Excel you must place your So I hope you can see my screen. So in Excel, we must place your job satisfaction, your X here, your X variable, the independent variables followed by the dependent variable, for you to stimulate the scatter plot and also the regression line. So now I'm going to show you how to do the scatter plot first. So for you to do the scatter plot, so what you have to do is firstly, you have to go and get the data, which is the job satisfaction, intention to leave, and the motivation. You have to copy the data set. Okay, so you just copy the data set and go to new sheet, and what you paste them. Okay, then what you do is, since this is the Y, so we want to look at the correlation between the job satisfaction and intention to leave. Okay, this is one set. Another one is motivation. Motivation with intention to leave. Another one more set, which is motivation with the we make the motivation as the dependent variable, and job set independent variable, the job satisfaction is the dependent variable. So we can stimulate 3 different scatter plots for us to look at the correlation between these variables. So to do that, so what we do, firstly, we name them as this is the the X variable, and this is the Y. And same goes for this. This is the X. Because if we are talking about a pairwise, this is pairwise correlation. So this is the X variable, and this is the Y variable. And now the same thing for this. This is the X, and you can see this is the Y. So with this, what we can do is we can produce the. I hope you can hear me. I hope you can see my screen.
Yes, can, sir.
Yeah, great. So with this, what we can do is we can produce the scatter plot. Scatter plot is simply by copying this data. Just go to insert and go to the recommended charts. You can click the recommended charts, but what is recommended is you go for insert scatter X and Y here. Just click for the scatter so you can see the scatter plot. And y, since you put this y, intention to leave, so y-axis, this y-axis will become your intention to leave, your x-axis will become the job satisfaction in this case. So you can rename it. You can rename it as the relationship job satisfaction. Tension. So now with this, from here, what you can do is you can also come up with the trend line, the regression line or the trend line, which we discussed earlier. So you can get the trend line here, but what you can do is you click more option. You don't click the trend line here. You go for more option. Click here, click the arrow here down here. So you can see the more options. So go for the more options here. And you select linear, and also you tick for the display equation on chart, and also display the R squared, which we discussed earlier. So as you do this, so you can see the regression equation is already here. So the regression, the y is equals to a plus bx is already appearing here with its what R squared. So the R squared value is 0.4852, which will become the 48.52% of the variation in the y, which is the intention to leave, can be explained by the job satisfaction. So it means we can say less satisfied workers, they have higher intention to leave, for example, right? So this is on the first one. So you can also make it differently. You can also double click this and you can choose whichever kind of diagram that you want to present. You can choose like this, or you can change the layout to be like this. If you want it to be like this, then you can change it like this, or you can also look for any other designs, types of designs, chart designs. You can adjust the chart designs, in other words. Okay, like this, or whichever that you think it is nice to see for you. So maybe I would like to use this. This is something new, latest, and looks different. So with this, so what you can do is you can try to explain that there is a negative relationship. Basically, you can see why, because you can see the plots. The scatter plots is downward trending. It is downward trending from your left to right, from your left hand side to right hand side. You see, is it going upwards or downwards? If it is going downwards, then you can clearly see there's a negative. Or with a regression line here, you can see a regression line here, straight line is going down. Dia pergi ke bawah, that from kiri to kanan, from your left to right. So you can see negative sign, and also you look at the slope here, it's also negative slope, you can see here clearly. So what we can do, we can just put this aside. So once the first diagram is introduced, we can even minimize it. You can take this diagram before you copy this. You can copy this and paste it in your assignment report before you do the conversion. What you can do, you can put them aside here. The same thing for the second set. You can just copy the whole of the data. Go for the insert, scattered. Do the same. Change the title, the relationship between this one with the motivation and intention to lead, between motivation and intention to lead. Motivation and intention to lead. So same thing, you can change the design that you want, and go to plus, then you can look for the more options. Click more options, then you make changes. make sure you select the linear and also click display equation, display R square. This will be a second diagram. Please make sure that it is the same size, or almost the same size, and do the same for the third one. Third relate to two variables, pairwise correlation. We're looking at motivation and also the job satisfaction, employee job satisfaction. Do the same. Go to the insert. Go to the charts. Go to the scatter plots. Again, we change it to the design that we like. So you can even copy paste from here. In motivation and intention to be. And job satisfaction. And go for the resize the diagram. So you can present them nicely like this. And even you can adjust the grid size. You can make it bigger if you want to. So next we should be able to interpret. So you can left to right, negative slope, and the variation in the y that explained by the variation in the x about 48.52%, or 48.52%. But for this case, you can see the equations are here. You can even make it a bit bigger if you want to. So you can see the variation is variation explained. The R squared value is very low here, 18.65%, 19% only. And for this case, you can see the variations is even more smaller. It's only about 14.46. The highest variation is this. You can see the job satisfaction. That means greater correlation. We can see the greater correlation over here, which is about close to moderate correlation. We can say roughly about a moderate correlation. Okay, so this is how we get the scatter plots. The same thing shown here from the example here. So this is how I did the correlation here. You can look at the sheet 2. And for you to do the correlation, for you to get the correlation coefficient analysis, not by using the scatter plot. So after scatter plot, you can also calculate the correlation. So how do you can calculate the correlation is it is by simply going to the data tab here, and you can look for the data analysis tab. So in the data analysis tab, you can see the list of analysis tools where you can do the descriptive statistics, correlation, covariance, regression, t-test, ANOVA, and all that. Even we have the two-factor and without replication, a number of 3 different types of ANOVA tests, including the single-factor ANOVA, one-way ANOVA, two-way ANOVA. Okay. So now, for now, what we need, we want a correlation. So we click here. So it will ask us to put in the input range. If you want to put in the input range, so we can just select the input range from job satisfaction, intention to leave. Just select the whole of this. Okay, as you select this, then you just tell the Excel that the labels in the first row, these 2 labels, the labels in the first row, and you select where you want the output range to be. Okay, you can just choose your output range. Let's say you want the output range to be here. Okay, then click OK. You can see the the result coming here. So you can see the result. So the correlation coefficient is about negative. The negative relationship is about 0.7. Very strong. Sorry, you can say strong correlation. You can say it's about strong correlation. And for the second correlate relationship, it's the first relationship, second relationship, and third relationship. We can do the same thing. So you go back to the data analysis tab, then you look for the correlation test. Click OK. Repeat the same thing, but now you have to erase. You have to erase this. You have to erase previous selections. And now you choose your input range. This motivation, intention to leave. You can include the labels from the first row until the last row carefully. Click OK. Then you tell the Excel that labels the first row and the output range, let's say you want it to be here, then you click here, then you click this box. So it will tell you that it is a J7, starting from J7. So column J, row number 7, you select it here. Then now you click OK, then you can see the result appearing here. So you can see it's only 0.4318. The correlation coefficient 0.43. It's moderate correlation, but here's a stronger correlation. Here's a moderate correlation between the motivation and intention to leave. Okay, so we can understand theoretically we can understand that job satisfaction, more satisfied a person, an employee is, the lesser intention to leave. That means the greater retention to stay. Workers' retention will be greater, or intention to stay will be greater, where intention to leave will be lower. So job satisfaction. At the same time, you can see motivation. We can also see the motivation as another factor. Higher the motivation, lower the intention to leave. The more motivated worker would like to stay the company that he or she is attached to. So we have the motivation. So from the data collection, let's see what is the motivation. So motivation, job satisfaction work together. But now if you see the motivation, what we can see, even though motivation is an important factor, but what we can see is job satisfaction is more important factor to consider compared to the motivation level. So when there is a question whether the management should focus on when it comes to retention, working towards the retention policy. If the management is focusing to looking at whether to increase the workers' motivation or to increase the workers' job satisfaction, which one is more important is from the data analysis we can see that the management should give more importance to workers' job satisfaction compared to the level of motivation. Okay. So now let us see what kind of relationship exists between the factor motivation, workers' motivation, and also the workers' job satisfaction. Do more motivated worker more satisfied, or the more satisfied worker is more motivated? Which way? So, but basically, it is not showing the causation here. But what we can see here is the nature of the relationship, and also the level of the strength of the relationship. This is what we are looking at. So now let us stimulate another correlation analysis. If we erase whatever previous inputs that we have here, so we just look for the sorry. If you wrongly clicked it, so please clear it and click it again. So select these two variables. Click OK. So label the first row. Choose your output range. So where you want the output to be. Let's say I want it to be here. So as you click here, it automatically you can see the row and column is appearing, which is column J and row number 12. You click it and you can see the answer. You can see the correlation between the level of motivation and job satisfaction is weak. We can say it's between moderate to weak. It's 0.3 smaller. But if you look at the nature of the relationship is positive. it is positive relationship. Okay, but if you look at the level intention to leave and job satisfaction, these are negative. So this is how you can explain. You can explain your correlation, your scatter plot with the correlation. This is considered a formal correlation test that you have conducted. The hypothesis, we can say there's no relationship between intention to leave and also job satisfaction. The alternative will be there is a relationship exists. So this is how we analyze it. Now let me just show you how do we do the data analysis for the regression here. So regression is the same thing. So for the regression, so what we can do is we can take all of them together. Let me just show you. And get the all three variables together. You need to say we have to have one y. Job satisfaction is the first independent variable. Motivation as the second independent variable. So we leave the gender aside first. So we estimate two models. The first model is a regression model. The second model will become, first model regression without gender. Second model, including gender as a control variable. Yeah. So now with this, what we can do, we can go for the data analysis tab. We look for the data analysis tab again. Go to the data tab, then look for the data analysis tab over here. Then look for the regression analysis test. Regression test. So for the regression test, so what we have to do is we have to include the y range. Y range. So y range we have to put here. This is the y. So we select the y. And for x range, we also select the x. And labels, output range, let's say I want it to be here. And if everything is okay, just click OK. So you can see the results are out. You can see this will be the regression coefficient. This will be the regression equation coefficient. This will be more like a multiple linear regression model. So we have the p-value. So all of these p-values are, especially these two, is considered zero. It's considered zero. And also this is also zero. We need to say statistically significant. But if you look at the motivation, is insignificant or less significant. It is not significant at 5% significance level. Alpha equal to 5% is not, it is insignificant. But for this case, job satisfaction is the most important factor. Okay. Sub factors of the motivation should be examined. So the management policy must be more focused towards the job satisfaction. From the assignment case study that I've given. I think I've answered your question here. So I think if no question, then you give a try. You give a try when you have the time. If you got any problem, then you can email me, or you can also chat with me through the chat box. Okay, so now what can we do is I will try to show you the other analysis also how other analysis like how we can use the so-called pivot table. For example, if you have a data like this, so you can explore, or you can also use the pivot table. You can go to insert here. You can go to insert, and you can just click the pivot table, and just simply click. Go to the or you go to the. If you do not know which pivot table to use, you just go for the recommended pivot table. But make sure you have selected the data. Click recommended pivot table. So why it's not working? We'll try another one. Okay, yeah, it's working now. So the same thing. So the same data. So what you have to do is you can go to the insert recommended pivot table. Click OK. Yes. So the pivot table will automatically help you to summarize the data. So the fastest way for you to do it is just by clicking the pivot table. So let me just show you one more time on how can you go to the pivot table. Go to insert, then you can click recommended. So recommended, what you will do is select the table range. Table range is select from the whole data. Click here and click OK. So it will ask you which type of pivot table that you want. Okay, you can choose any type of. So let's say you are going for this. Just click OK. So you can see it will automatically summarize for you as you click on this. So you can choose whichever variables that you want. Let's say you want to do the variables. You want to look at the age and also gender. You do not want. You want to summarize the age and gender. So you can see, just click age and gender, and if you want to sum it or you want to put, you can change the value, whether you want the total or you want the average, you want the count. If you want the count, just click OK. And you can also have them in rows. You can have them in rows and also the column. And if you want to include a type of contract, you can do like this. And include the education also. And you can try to, since your gender, your age is not a categorical variable, so you have removed your age. And maybe you can talk about the type of contract and also gender. Okay. So you can look at the type of the contract and gender. So this is how we can summarize. And if you want to come up with a diagram, you can also insert. You can also go for the recommended charts, and click OK. So you can see this is how gender. I mean, this is how the row, the sum of gender and type of the contract. If you don't want the sum of the gender, you can also go to the sum of the genders here and change the field setting you have to go for the average of count. You can see how many row one type of contract and also the count of gender. So you can see you can produce a diagram over here. Or if you don't want a gender, then you can also go for the level of education. Level of education. If you want an average, you can also do the change skill setting here. Go for the average. So you can even change this the diagrams here. You can edit the diagrams. So you can try to use the pivot table, or you can also do it manually. If you want to do it manually, you can also do it manually, especially for the categorical variables. You can see I can do it manually by just simply sorting them. By simply sorting them. So for example, you can just do the sort filter. You can just select this and go to the sort filter. So as you filter it, you can also get the count for only male. Okay, how many males we have? We have 10 males. So you can see the statistics below here, 10 out of 50, 10 males, the rest all female. Okay, so since we already know the count, so what we can do is we can produce the diagram. So how we can produce the diagram? We can open up a new table. So how many males? Male versus female workers. So we can get the count. So the total. So we know total we have about 50 people. Okay. So how many percentage of male? 40 automatic, because we already know the count is what? 10 male, 40 female. So with this, what we can do, we just select them and just go to the insert again. You can use the pie chart. You can stimulate a pie chart. You can choose the kind of pie chart that you want. So this is an example of how you male and gender. For the factor gender, or maybe even you're going to show the fractions. So how many percent of them are male? How many percent of the workers? The gender of the employees in the company that we are looking at. So 20% male. About 80% of the workers in the company X is female. That's how we can present. So now we can also show, we can also do a manual sorting for us to identify how many of them following a type 1 contract, type 2 contract. So you want to sort for the type of contract. So type of contract we have 1 and 2. So how many of them contract full-time job, full-time and part-time type of contract. So 37 of them is 37 out of 50. The total is 50. 37 of them are number 1. So type of contract. So we can see full-time workers, part-time. So full-time is 37. Total we know 50. So 50 minus 37, we will know how many part-times. Or if you want to do it by sorting, you can just go to the type of contract. You can uncheck 1 and select 2. You can see 13 will be down here. It will show you the records. How many records? 13. So automatically 13. The balance will be 13. So with this, you can also come up with another pie chart and type of contract. This is how we can produce the charts, and can choose if you want the percentages. You can also show like this. the table. You can use the table as well as the percentages. Going to go for like this. You think this is good for you. So you can choose whichever diagram that you want. So full time versus the part time, a type of contract. So you can still edit the title. Full time and part time. So you can also talk about the count as well as the percentages. So now, so if let's say you want to do a cross tabulation, for example, if the question is asking you to do a cross tabulation, so if it is asking you to do a cross tabulation means we're going to tabulate together. Basically, for the cross tabulation, what we have to do is we are, let's say you want to tabulate male gender by, you want to do a gender by type of contract, gender by type of contract. So let's say you want to do the cross tabulation. So let's say you have a gender by, so you have a gender male, female. And you must put in a total over here. So let's say you got a contract, type of contract, let's say you got a full time and part time. And you have to put in the total over here. That means we want to see, specifically, we would like to look at how many, this is what we call a cross tabulation. We can do cross tabulation for categorical variables only. So we have two categorical variables here. So earlier we looked at the totals of full times and part times, totals of males and females. So we can go into the cross tabulation where how many male are full time, how many male are part time, how many females are full time, how many females are part time, and we're going to look at the cross tabulation here. So how to do this? By simple sorting only in Excel. We go back to the Excel, make sure we clear all sorting, clear everything first. What we do without even using a pivot table. So we clear again one more time, make sure we have cleared everything. Okay, all of these will be cleared. So now what we do, we are just targeting the two variables, gender and type of contract. So two stages of sorting. So what we do, we sort for one for men, male. So type of contract, you can see all one. That means we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 male. Okay. So and all of them are full time. So what we do, we just put here. Male, how many? Total males are 10. Total females are 40. So how we get the total here? We got the total from here earlier. Okay, we know from here. And we know total full time, including male and female, is 37. Total full time is 37. Total part time is 13. So grand total is 13 plus 37 is 50. So it is matching. 10 plus 40 is 50. This is matching. So this is how we do the cross tabulation now. So now out of 10 males, all 10 males are full-time workers. And we found zero part-time. This is how we do manually. And out of 40 females, now we want to find out how many females. So, or we don't need to even find out. We just fill in the blanks here by using our simple maths. Okay, like 37 minus 10 is 27. We don't need to fill. We need to do an analysis here. 13, 0. 13 minus total is 13. 13 minus 0 is automatically we know value here. So with this, what we can do is we can just select this. No need to include the totals here. Excluding the totals, just select this, go to insert, go to recommended charts. You can choose the charts that you want. So this is how it looks like a cross tabulation chart. A gender cross tabulation, gender versus type of fund. So if you want to change this diagram, so if you're not really happy with the diagram, you want to make changes to the diagram. So you can look for other kind of diagrams here. Whichever diagram that you think is nice for you. Okay, so I think I've showed you how to stimulate that. So you can watch some videos, and I also will be sending you some links through the email or through the Moodle. You can find out from there. So now what I'm going to do is I'm quickly going to go through with you on the SIMS, on the manual calculation. So I think for the earlier session, I think we have already discussed on the topic 9. I think we have just discussed topic 9. If you look at the SIMS here, we have already discussed on the topic 9 on the simple linear regression. We discussed about a prediction. We also discussed about a line of best fit. Some questions and answers we have discussed. And also the correlation, positive correlation, negative correlation, no correlation. This just in case when you want to interpret, you can go back to the correlation. Whether it's upward sloping or downward sloping, or there's no trend. If you can't find any trend, then you can say it's no correlation, where we need a formal test to confirm on this. Remember, I show you the Excel. This is the scatter plot that we're talking about. Basically, if your scatter plot shows like this, okay, then you can conclude positive trend, a positive correlation. If your scatter plot it shows like this, then you must say it's a negative correlation. Okay, if your scatter plot like this, and when you come up with a straight line and it is mandata, it is a horizontal line, then you can say it's a no correlation or zero correlation. You can suspect for no correlation, zero correlation. So I think we have done the self checks and everything. And also the least squares method we have just discussed. All right, so now shall we continue our discussion for a couple of minutes? Okay, shall we continue with the discussion?
Can, sir.
Okay.
You'll need unlock your iPhone first.
All right, so now the topic is basically on the sample correlation. So we're going to look at I'm going to discuss on understanding the concept of correlation. Are we ready? Yeah, can you guys hear me?
Yes, sir.
Okay, so today we will explore the concept that shows how two things can move together. Sample correlation, sample correlation.
Okay,
So
because
any
I
idea?
think
Yeah.
I think correlation shows whether two variables are related.
Perfect. A positive correlation. The relationship between two variables, where it can be a positive correlation as one variable increases, another variable also will increase. So correlation basically helps us to understand the direction and the strength of a relationship between two quantitative variables. So now let us discuss what is correlation. Correlation coefficient specifically. So the term R, the correlation coefficient usually written as the R value. So it tells us two things. One is the direction, whether positive or negative. whether positive or negative direction, the nature of the relationship, whether it's a positive relationship or negative relationship. Another one is the strength of the relationship. The strength of the relationship, it shows about how closely the points fit a straight line. And must also know the range of the correlation. The range of correlation is between -1 to positive. So basically 0 to 1, but we have the negative as well as the positive relationship. So negative doesn't mean the value is smaller. No, it is not like the running number, but basically it is more like the nature of the relationship. Okay, sometimes you can see that the relationship between profit and cost is negative. The relationship between profit and revenue is positive. We cannot say positive is always better than negative. No, the nature of the relationships, they are negatively related. These two variables are positively related. So that doesn't mean the negative value. For example, in running number, we say 0 is a greater value compared to -1. Or 1 is a greater value compared to 0. That is a running number. Now, when it comes to correlation, it is a correlation coefficient. So the term coefficient means Pekali. It's a coefficient that showing us the nature of the relationship. Okay, the type of the relationship, how the two variables they are related. Okay, all right. So when we talk about +1, it means the perfect positive correlation. -1, perfect negative correlation. 0 means we get no correlation.
Okay, so if R is 0.8, sir, the two variables are strong related, sir?
Exactly, and they move in the same direction. And now, what if R value is equals to -0.9?
Okay, that would mean a strong relationship, but if they move in, but they move in opposite directions.
Well said, correct. That's a strong negative correlation. Right? So now let us talk about how to interpret the correlation coefficient. So let me just give you some values and you try to interpret. Okay, so I give you, let's say, 5 different R values. So the first one is R value equals to 0.98.
It's a very strong positive relationship.
Very good, fantastic. If -0.72,
It's a strong negative relationship.
very good. How if the R value is 0.10?
Is a very weak positive correlation, but it's almost done. Almost none, sorry.
None, yeah, almost none, yeah. So how if R equal to 0?
No relationship at all.
No relationship at all. And let's say, okay, let's say if R is -1.
No, it's a perfect negative correlation.
Yes, 1 means perfect. So -1 is perfect negative correlation. Fantastic answer. Now, be careful. Correlation does not imply causation. This one you have to remember. So now let us move into the real life examples and applications on correlation. Let's explore the real world correlations. I'll list a few pairs of variables here. You tell me whether you would expect a positive correlation or a negative correlation or no correlation. So first case, let me just give you a first case scenario. Hours of exercise and weight loss.
It's a negative correlation because more exercise, less weight.
Great, correct answer. More exercise, less weight. Less weight. Okay, so let's say I give you another example, which is number of TVs in a house and household income.
Probably positive because the richer families may have more TVs.
Correct. So possibly a positive correlation. And how if I say number of pets and final
Obviously, no
That makes
relationship, sir. Sir?
Yes.
Okay.
Correct answer.
Obviously, no relationship. Because
No
R
no
is
relationship.
none.
Great. Excellent. So now let us look at a data example. I just give you the study hours and exam scores. We go back to the previous example. Let's say we have 1, 2, 3, 4, 5. Just take a simple running number of 1 to 5 for X values. 1, 2, 3, 4, 5. And exam score 1 for 50. You can take it down. 1 for 50, 2 for 55, 3 for 65, 4 for 70, and 5 for 75. Okay, so you can see a pattern there. So what pattern we can guess? We can see the greater the number, the greater the exam scores also. So this shows a positive linear relationship. So if we are
Yes.
calculating R for this data, would it be close to 1?
Because the points
it
are
would be,
going up together.
Yes, exactly. If you plotted this in a scatter plot, it will be almost a form of straight line for your information. So now, the formula, I think you have already seen the formula in the sheet, the self-instruction material.
Yes.
The formula, you can see the R value formula. So I think I'm not going to tell you the formula. Okay. Okay. So, but although the formula looks so complicated, we normally use a software or calculator like to calculate most of the time. But you should also understand what you are doing. So it's
Yes.
basically the numerator of the formula is the covariance. Covariance, covariance and divided by their standard deviation. So covariance of X and Y divided by the standard deviations, a product of standard deviation. So for now, let us take a simplest example. Let me just give you X values. If I give you X values of 246, okay, you can just take 246. X value equal to 246. Y value is 369. 246, 369. Okay. What can you see?
Okay, I can see that both variables go up together, sir. So the correlation should be close to +1.
Exactly. This is a perfect positive linear relationship where you can say R value is equal to 1. It's exactly the same. So now, ethical issues are sometimes misinterpretation and also cautions when it comes to correlation. Now, let's look at the ethical side. Adiza, why might it be dangerous to misinterpret a correlation?
Okay, so if we can say one thing causes the other when it doesn't, it might be wrong decision making. Like blaming video games for poor grades without considering other factors.
Brilliant. That's a co-founding variable. Maybe students who play video games also sleep less. That affects the grades. So common mistakes in correlation analysis includes like inferring causality without proper evidence, or ignoring lurking variables, or over-interpreting big correlations, cherry-picking data to show stronger correlation. So all these are common mistakes.
So we must use correlation carefully, especially in public reports, sir.
Yes, transparency is important. So ethical analysts, they normally disclose full data set, avoid exaggeration, and also state limitations in the analysis, and also they use correlation when one variable are quantitative and linear. So shall we wrap up final practice?
Sure, sir.
So we will end with this final practice. We will stop with the final practice where I will give you some questions, then you just try to answer, and we will stop here. Okay. So
Okay.
let's wrap up with the review. So what is the range of R?
It's from -1 to +1.
Nice, fantastic. So what does a correlation of 0 mean?
There is no linear relationship.
No linear relationship. Correct. So what is the main rule about the causation?
Correlation does not imply causation.
Great. What does a negative R mean?
As X is increases means that Y it decreases.
Fantastic. So last question, should we extrapolate from correlation graphs?
No, because the correlation describe what exists in the data, so means that prediction need regression.
Great. So I think we stop here for today. Great discussion. So thank you very much for joining, both of you.
Thank you so
So
much,
have
sir.
a great
I
day. Yes,
sincerely
thank you.
appreciate the knowledge that you have shared. Thank you, sir.
Thank you, Diza. Thank you, Ikmal. So we shall end the session for today.
Okay, thank you, sir.